Welcome to Programming Fluency. This is section 2.4, Operators and Expressions. You already know how to store a number in a variable. In this video, you learn how to do something with it. You add, compare, and combine values using operators. Let's begin. In this video, we learn how to combine values and see storing a number is nice, but it is not useful until you can do something with it. Operators are the tools that build every calculation. Here is the plan for this video. First, the arithmetic operators. Add, subtract, multiply, and divide. Two of them surprise beginners. Integer division throws away the remainder, and modulo gives you the remainder. Next, the relational and logical operators. Relational operators compare two values and give you true or false. Logical operators combine conditions, using and, or, and not. Then, compound assignment and increment. These are shorthand forms, like plus equals, along with the increment and decrement operators that add or subtract 1. After that, precedence and associativity. Precedence decides which operator acts first when there are no parentheses. Associativity breaks the tie when two operators have the same precedence. Finally, common bugs. We look at confusing 1 equals sign with 2 and letting integer division quietly ruin a calculation. Let's start with a small puzzle. What does 2 plus 3 times 4 equal? Is it 20 or 14? The answer is 14. C follows the same rule you learned in math. Multiplication happens before addition. But C has more than 40 operators and 15 levels of precedence. Multiplication before addition is just the beginning. Let's define the key word. An expression is any combination of values, variables, and operators that produces a result. Every calculation in every C program is an expression. Here are the arithmetic operators. These do the calculations you already know from math. The plus sign adds two values. 7 plus 3 is 10. The minus sign subtracts. 7 minus 3 is 4. The star does multiplication. 7 times 3 is 21. The slash does division. 7 divided by 3 gives 2 here, and we will see why on the next slide. The percent sign is the modulo operator. It gives the remainder. 7 modulo 3 is 1. 5 of these work just as you expect. The sixth one, division, has a surprise that catches beginners all the time. Let's look at it closely. When both operands are integers, the slash throws away the remainder. The result is always a whole number. So 7 divided by 3 is 2, not 2.333. Watch out for this. 1 divided by 2 is 0, not 0.5. Both operands are integers, so the decimal part is discarded. If you want a decimal result, make at least one operand a floating point number. 1.0 divided by 2 gives 0.5. The modulo operator, written with a percent sign, gives the remainder after integer division. It works only with whole numbers. 7 modulo 3 is 1, because 7 is 2 times 3 plus 1. 10 modulo 5 is 0, because 5 divides 10 evenly. Modulo is more useful than it looks. You can check even or odd. A number modulo 2 is 0 when it is even, and 1 when it is odd. You can wrap a value around so it stays in range. An index modulo, the size keeps the index inside the array. And you can pull off the last digit of a number. A number modulo 10 gives its final digit. Comparison operators compare two values. The result is always an integer. C splits these into two families, relational and equality. 1 means true. 0 means false. Less than, this is a relational operator. 3 less than 5 is true, so it gives 1. Greater than, also relational. 3 greater than 5 is false, so it gives 0. Less than or equal, and greater than or equal round out the relational family. Equal to belongs to the equality family. It uses two equal signs, double equals. Notice that. A single equal sign means something different, and we will come back to that. Not equal is the other equality operator, written exclamation equals. 3 is not equal to 5, so it gives 1. Because the result is just an integer, you can store it in a variable. Here is adult gets 1 if age is at least 18 and 0 otherwise. Logical operators let you combine conditions. This is how you say this and that, or this or that. The double ampersand is logical and. It gives 1 only when both sides are non-zero, that is, both true. The double pipe is logical OR. It gives 1 when either side is true. The exclamation mark is logical NOT. It flips the value. Not 0 is 1, and not 42 is 0, because any non-zero value counts as true. In the example, age is 25 and has id as 1. Age greater than or equal to 18 is true and has id as true, so the AND gives 1. Here is an important behavior called short-circuit evaluation. C reads a logical expression from left to right, and it stops the moment the answer is certain. For AND, if the left side is 0, the whole thing is already false, so C does not even look at the right side. For OR, if the left side is non-zero, the whole thing is already true, so C skips the right side. Look at the example. First we check that the denominator is not 0. Only if that is true does C evaluate the division, so we never divide by 0. This is a guarantee you can rely on, not just in optimization. C gives you shorthand operators that combine an arithmetic step with assignment. Instead of writing x equals x plus 5, you write x plus equals 5. It adds 5 to x. X minus equals 3 subtracts 3 from x. X times equals 2 multiplies x by 2. X divide equals 4 divides x by 4. These do exactly the same thing as the long forms. They are just shorter to type. Total plus equals price says add price to total, which is more direct than total equals total plus price. C has increment and decrement operators. Both x plus plus and plus plus x add 1 to x. The difference is about timing, and it only matters inside a bigger expression. Let's trace it. X starts at 5. Post increment, written x plus plus, returns the current value first, 5, and then bumps x up to 6. So it gets 5. Pre-increment, written plus plus x, bumps x up first from 6 to 7, and then returns the new value 7. So B gets 7. When you use it on its own line, the two forms are identical. Both just add 1. So keep your code simple and readable, and avoid clever one-liners. Here is the expression tree for 2 plus 3 times 4. Start at the bottom with the leaves. 3 and 4 are the two values under the multiply node. 2 sits on its own under the plus node. Evaluation flows from the bottom up. Multiplication binds first, because it has higher precedence. So the multiply node acts before the plus node. 3 times 4 is 12. Now the plus node can act. It combines 2 and the 12 we just computed. 2 plus 12 is 14. That is why 2 plus 3 times 4 is 14, not 20. This is what precedence means. Precedence decides which operator acts first. A higher precedence operator binds more tightly, so it sits lower in the tree and acts sooner. You can always override precedence with parentheses. If you write open paren 2 plus 3 close paren times 4, then the addition happens first, and you get 20 instead. Here is the precedence table for the operators you have learned, from highest at the top to lowest at the bottom. You do not need to memorize this. Focus on the patterns. The unary operators act first. That is prefix plus plus and minus minus, logical not, and the unary minus that negates a value. Next come multiply, divide, and modulo. Then add and subtract. Then the relational comparisons, like less than and greater than. Then equality, that is double equals and not equal. Then logical and. Then logical OR. And assignment happens last. So arithmetic runs before comparison, comparison runs before logic, and everything runs before assignment. When you are not sure, just add parentheses. They cost nothing and they prevent bugs. When two operators sit at the same precedence level, associativity breaks the tie. It tells us the direction of grouping. Most operators group left to right. So 10 minus 3 minus 2 is read as open paren 10 minus 3 close paren minus 2, which is 5. The leftmost operator goes first. Assignment is the famous exception. It groups right to left. So A equals B equals C equals 10 is read from the right. First C gets 10. That returns 10, so B gets 10. Then A gets 10. All three variables end up holding 10. Let's trace some code to build fluency. Score starts at 100. Score minus equals 15 makes it 85. Score times equals 2 makes it 170. Now count starts at 10. The first print uses count plus plus. Post increment returns the old value 10, so it prints 10, and then count becomes 11. The second print uses plus plus count. Pre-increment bumps count to 12 first, then prints 12. Remember precedence 2. 5 plus 3 times 2 does the multiplication first, giving 11. 10 divided by 3 is integer division, so the answer is 3. But 10.0 divided by 3 has a floating point operand, so you get 3.333. Here is a classic trap. We convert 72 degrees Fahrenheit to Celsius. The formula is F minus 32 times 5 divided by 9. Version A uses whole numbers. Version B uses floating point numbers. Let's see why version A fails. Fahrenheit minus 32 is 40. 40 times 5 is 200. Then 200 divided by 9 is integer division, which truncates to 22. The decimal part is gone before it ever reaches the double variable. Version B writes 5.0 and 9.0. That forces the whole calculation into floating point, and you get 22.222, the correct answer. Here is one of the most common bugs in all of C. A single equals sign is assignment. A double equals sign is comparison. Look at the buggy code. Inside the if, we wrote x equals 5 with one equals sign. That is an assignment. It stores 5 into x and it returns the value 5. Because 5 is non-zero, C treats it as true, so the if body always runs. And worse, the original value of x is gone, overwritten by 5. The fix is to use two equal signs, which means compare. A helpful habit is to compile with the -w all flag. Many compilers will then warn you when you put an assignment inside an if condition. Let's recap. Operators build every computation and see precedence and associativity decide the order. The arithmetic operators are plus, minus, star, slash, and modulo. Remember that integer division truncates, and modulo gives the remainder. Relational operators compare two values and give 1 or 0. Logical operators combine conditions, and they short-circuit to avoid extra work. Compound assignment and the increment and decrement operators are handy shorthand. Precedence decides which operator binds first, and associativity breaks ties when precedence is equal. When you are unsure, use parentheses, and never confuse a single equals sign with a double equals sign. Next, in section 2.5, we look at what happens when you mix an int and a double in one expression. You will learn how C converts between types, and how to define constants that never change.